Before we can talk about inverses of matrices, we need to talk about what an identity matrix is, because in order to have an inverse operation, we must have an identity. Okay, so let me just show you this. The 2 by 2 identity matrix would be simply the matrix where you have 1 down the diagonal as you go from the top left to the bottom right, and then every other entry would be 0. And identity matrices have to be square matrices, so this would be a 2 by 2 identity matrix. Now for a 3 by 3 identity matrix, it would look like this, where you have again 1s down the diagonal as you go from the top left to the bottom right, and then 0s in all the other entries. And a 4 by 4 matrix, identity matrix, would look like this. Again, 1s down the diagonal from the top left to the bottom right, and 0s everywhere else, and so on. So I could show you larger 5 by 5, 10 by 10, and so forth, but basically that's what identity matrix will look like. Okay, now the property for identity matrices is simply that if you take a matrix, say a matrix A, and you multiply it by an identity matrix called I, then A times I always equals A, and I times A would equal A. And we call this matrix I the multiplicative identity, or just the identity of A. Now there's also an additive identity, which is just the 0 matrix, but I won't spend much time talking about that. So for example, one here, let's say we have the matrix 2, 5, 3, 1, and we multiply it by the 2 by 2 identity matrix. Now we know, since this is an identity matrix, as long as the product of these two is defined, we know by definition that if we multiply the matrix A times this identity matrix, in other words, if I take the matrix 2, 5, 3, 1 and multiply it by this identity 1, 0, 0, 1, then it must return the actual matrix that I multiplied by it. So it must return the matrix 2, 5, 3, 1. So in other words, A times I is just going to equal A. And also you can show that I times A, if you reverse it, it's going to also equal the matrix A. And this will be true for any 2 by 2 matrix A. Now also, if you wanted to, let me show you an example of where I take the 3 by 3 identity matrix and multiply it by a 3 by 3 matrix. So if I took this 3 by 3 matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 and multiplied it by the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, then the result would just be this matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Or if I turned it around and multiplied the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9 by this 3 by 3 identity matrix, it would just return the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. And this would work for any 3 by 3 matrix that I put in here. Okay, now as I said, there is an additive identity, but they're not much use for us, so I won't spend much time talking about that. But the 2 by 2 additive identity, I should say identity, not inverse there, so take that out. But anyway, the 2 by 2 additive identity would just be this matrix with all zeros in it. And if you add a 2 by 2 additive identity to any matrix, it just gives you that matrix. So we won't spend much time dealing with that. Okay, just a quick note about real numbers. With real numbers, the multiplicative identity is just the number 1, because if you take a number and multiply it by 1, or you take 1 multiplied by a number, it always returns that number. Now, real numbers and matrices are not the same set. They're different sets. So the identity of a real number is a number, but the identity of a matrix is a matrix. So the multiplicative inverse of a real number, a is the number 1 over a, because if you take a times 1 over a, you get 1, which is the identity for real numbers. The same logic holds for matrices, but the inverse of a matrix would be another matrix, not a number. So two square matrix whose product is a matrix identity are said to be multiplicative inverses, or just inverses. So with real numbers, if you multiply 2/3 times 3/2 and get the number 1, we know that these two numbers are inverses of one another. Well, with matrices, if you have two matrices and you multiply two matrices together and get the multiplicative identity of one another, then we know that those two matrices are actually inverses. So these two matrices are inverses because when you multiply them together, you get the multiplicative identity. And so that defines what a matrix and its inverse will be. So the formal definition of this is if A is a square matrix and B is another square matrix such that their product is the identity matrix, then B is said to be the inverse of A, and likewise A is also said to be the inverse of B. And we denote A inverse as A raised to the -1. Now, this does not mean 1 over A, because there is no division operation for matrices. So there's two things that we might ask you to do. One is we might ask you to show that two matrices are inverses. So I might give you two matrices and say, hey, can you show me that these two matrices are inverses of one another? And so if I do that, that's pretty simple, because all you have to do is show that, first of all, they have to both be square matrices of the same size. And then you must show that their product gives you the identity matrix. So here, to show that A and B are inverses, I just multiply them together. So if I multiply these two matrices together, let's do that real quick. This row times this column would give me 3 minus 2, which is 1. This row times this column would give me minus 3/2 plus 3/2, which is 0. And then this row times this column would give me 4 minus 4, which is 0. And then this row with the second column would give me minus 2 plus 2, which is, let's see, no, it's minus 2, sorry, it's minus 2 plus 3, which is 1. So that gives me the 2 by 2 identity. And I'll let you check it the other way. If you multiply B times A, you should also get the 2 by 2 identity. So since these since the product of these two matrices do yield the 2 by 2 identity, we know that these two matrices must be inverses of one another. And so in the next video, I'll actually show you how to find the inverse of a matrix. Here, I actually gave you these two matrices. But what if I just gave you one matrix? What if I just gave you this matrix and asked you to find the inverse of this matrix? And so that's what I'll talk about in the next video.